Yes, students, some more examples we are going to discuss in this. It's a continuation for that. Just you can see this is nothing but cyclopent dienzyl ion. So either it may be anion or cation or free radical. So since it is having negative charge, we can able to take it is called anion, it is cation, and it is free radical. See, if you observe this, just it is nothing but cyclopentadienyl anion. Here, first condition it is cyclic and planar, and whether it is in the conjugation or not, just we can able to see here. See here, there will be two electrons or total pi electrons are two, total pi bonds are two, electrons are four. Just here you can see, here also there will be two electrons. One electron is belongs to this carbon, the extra electron is come from other one like H plus something like from other atom. Anyhow, total pi electrons how many in this? Just two pi bonds with lone pair. So if only pi bonds involved in conjugation like this, the pi bonds will revolve. So there will be no complete conjugation happens. When this lone pair involves in conjugation, yes, at that moment, the complete conjugation is taking place. So in this case, how to identify total number of electrons involved in conjugation? Just to two pi bonds, so that 2 into 2, 4 electrons from two pi bonds. And then we are also having one lone pair or one negative charge, so which is also 2. So total how many electrons involved in conjugation? Yes, 6 electrons. If it involves 6 electrons, then which compound it is? Yes, it is following Huckel's rule. That's the reason this compound will be under aromatic compound. This comes under aromatic in nature. Now coming to the second one, this one. Just you can see here. So here conjugation taking place since the positive charge is there here. But what is happening here? Since the double bonds are located and those are making conjugation with respect to positive charged cation. So complete conjugation is happening, but it doesn't have 6 electrons or 2 electrons. It is having 4 electrons in the conjugation. That is why 4 electron system means which one it is? Yes, it is comes under anti-aromatic in nature. It comes under as anti-aromatic compound because it is obeying 4 and pi electron rule. And coming to the next one, just free radical. So here conjugation is happening throughout the ring. Why? Because free radical or carbocation both are electron deficient in nature. That's the reason the pi bonds will move with respect to free radicals. Like if you see little bigger, you will understand better. Just here, the pi bonds are present. So this lone pair or this not lone pair, this pi bond can make conjugation with respect to free radical since free radical is also deficient. But here total how many electrons involved in conjugation? 2 into 2, 4 pi electrons, and there will be one more electron here, that electron also involving. That is why total how many electrons involving in conjugation? 5 electrons. So you will not get any 5 electron either in 4n pi rule or 4n plus 2 pi rule. That's the reason this is not comes under aromatic or anti-aromatic. It comes under non-aromatic in nature. So this is one way to define aromaticity and other things. Now coming to the second, this fourth example. So in this, generally this aromaticity concept applicable for mono ring compounds. But some other compounds like more than one benzene ring connecting like this, even those compounds also obeying aromaticity. So here also make conjugation throughout the ring. So here also, sorry, this pi bonds will not be like this. Just pi bonds will be in this way. Just pi bonds will be like this. So what is happening? There will be conjugation throughout the rings. So that is why total how many pi electrons involved in this, students? 5 into 2, 10 electrons are involved. If 10 electrons involved, which rule it follows? Yes, Huckel's rule. That's the reason even naphthalene, this is nothing but naphthalene and anthracene is also obeying aromaticity. And coming to the next example, which is this. See, these compounds we can call it as annulenes. Annuline is nothing but the hydrocarbons which are having alternate double bonds. Those compounds can be called as annulenes, and those are also present in the ring form. And here, how to give IUPAC name for annulenes? Just you will see that. Very simple. Just find the total number of carbons involved in this. So total carbons will be 3, 4, 5, 6, 7, 8, 9, 10. So total we have 10 electron involved, 10 carbons involved in this. So that this we can able to tell like 10 annuline. So just to 10 we have to put in bracket and we have to write annuline. And the double bonds will be at alternate positions. If you observe this compound, it is having ring combination, like it is in the form of ring, and it is also in the conjugation. Just you can see the double bond movement, how it is. And so it is also having conjugation throughout the ring. And coming to the next one, and it is also obeying 4n plus 2 pi rule. Why? Because total electrons, how many involved here, students? N value will be, suppose if you take 2, you will get 10 electrons. So here in this example, 5 pi bonds are involved. So we get total 10 electrons in it. So that's the reason it is obeying 3 conditions. But the problem is it is not obeying planarity. What does it mean? Here the carbons, those are like this carbon and this carbon. If you observe, the hydrogens of those carbons, the hydrogens of those carbons are not at same direction. Those are at opposite direction. That means this hydrogen will be this direction and this hydrogen will be this direction. So that is why this annuline is obeying all the 3 conditions of aromaticity except planarity. That's the reason annuline doesn't exhibit aromaticity. So hope it is clear about annulines. Now coming to the next example, that is this is nothing but a cyclic with keto group. So these we can also call it as cyclic ketones. So here just how it will be and how to explain aromaticity in this, you have to understand. Here carbon will be here, oxygen will be, just I will elaborate that structure and write. See students, here carbon will be here, oxygen is there. We already know that carbonyl compounds are mainly undergo nucleophilic addition reactions. So in this case, the pi bond, this CO bond will split like this, O minus and carbon plus, due to high electronegativity of oxygen and low electronegativity of carbon. So this pi electron shifting here. So after shifting, we get this type of compound. So here, this positive charged carbon we got, along with that there will be one pi bond inside. So just we can see that. See, this pi positive charged carbon neutralizes when this bond is shifting here. When this positive charged carbon neutralizing by moving this pi bond, which means what? It is making conjugation with respect to positive charged carbon. So now after coming that pi bond here, here positive charge is formed and this will become neutralizes. See what is happening, since this positive charge is moving this side, this carbon gets positive charge and this positive charge is neutralizing. So again what happens, this will come here. So what you need to understand here, the positive charge, due to formation of positive charged carbon in this intermediate, the pi bond is moving throughout the ring and making complete conjugation. So that is one thing. And here total how many electrons involved in conjugation? Yes, just only one pi bond is making conjugation throughout the ring with respect to positive charged carbon. So if you get two electrons, then what is the result, students? Yes, it is obeying 4n plus 2 pi electron rule, because n value if you take 0, you will get total electrons are 2 pi electrons, right? So that is the conclusion of this, students. So conclusion is what? This compound can obey aromaticity. So cyclopropanone exhibit aromaticity. Thank you, students. Just you can see these two examples. Tell me whether it is obeying conjugation or not. Even assuming obeying conjugation or not, you can put in comments. Thank you.